What's up, YouTube? It's your favorite math teacher, Mr. Stevener here, coming at you with another video. If you go ahead and hit that subscribe button for me, that way I can create content just for you and you get updates, all right? Or you can comment and let me know, hey, I need help with this. Tommy and I were just talking today. It's like, I love making these videos to help you guys. It's a lot of fun for me. I know Tommy's learning a lot and he has a lot of fun. So, this is for you. Secondly, this video is going to be all about writing equations using slope, unit rate, and constant of proportionality. If you don't know what those are, go watch that video up there on that eye. It'll help you out first because you got to be able to find those before you can write an equation. All right? Let's get started. Tommy, come here real quick.
Okay, what are we doing today?
We're writing equations.
Oh, equations, huh? Yeah. I don't know what those are.
Well, I'm here to tell you what those are. That's really an important thing to know, Tommy. So let's get started then. So first off, you have to understand there's some terms you need to know when it comes to an equation.
Okay, some terms I need to know.
Exactly. First off, you need to know what an equation is. That is slightly important, okay? Understand it has the equal part of it. That basically means that an equation has an equal side. We treat it like a balance, right? It's a scale, meaning one side of the equation is equal to the other. It has to. You've actually seen this since you were like in first grade. Something like this. This is actually an equation.
It is?
Yeah, 2 plus 2 is equal to 4. You have this side of the equation, 2 plus 2, is equal to this side of the equation. That is called an equation.
Oh, okay.
You've actually even seen equations with missing things. For example, you might have seen something like this. 2 plus a box is equal to 4.
Oh, no.
I know, it's like, oh no, what's inside the box?
Well, it's 2.
Exactly. So the box, in this case, is equal to 2. Okay? That's basically called solving an equation, and we'll definitely make a video on solving equations. That's coming soon, don't worry. But one of the things that's really important about an equation is this word right here that I'm about to put on, which is called a variable. Okay, this is a very important concept in math, okay, is a variable. And a variable is something that is unknown, okay? They even call it the unknown, and a lot of times you've actually seen it as x.
Oh, yeah, I have seen X. Why are they putting letters with math, though? It's numbers.
I know. People say that all the time. Why are we putting letters with math? It's just the way it works. Because really, we put a letter because we represent something unknown. You've actually done it in the past where it's a box, like I told you.
Oh, wait, it's the same thing?
Sure. In an equation where we use x, we would just do this instead.
Oh, so it's kind of like the box.
It's kind of like the box, exactly. So we would have 2 plus 2 equals 4 is the answer. That means x is equal to 2. So that variable, that unknown, is 2. Now, obviously, that's a lot easier to find that unknown using that. But really, it's really important. Variables are something that we don't know. It can also be represented as one number or a bunch of numbers, and I'll explain that in just a second. But these are really important concepts, equation and variable.
Equation and variable. Got it.
All right. So with that in mind, we're going to take a look at some real-world examples here. If I can find my cursor, there it is. We're going to take a look at some real-world examples. I figured this would be helpful when it comes to writing our equations, and I'll explain why we do it as we go. Okay?
Okay, yeah, let's do it. Do it.
All right. So Francisca and Elizabeth are participating in a walkathon, right? Every school does jogathons and walkathons, right?
Oh, yeah, I remember those. Yeah, cool.
Fundraiser. Each girl walks for 3 hours. Ooh, that's interesting. How much will they raise together? Okay, so this is about raising money. Each girl's walking for 3 hours. That tells me this is going to be a unit rate problem. Okay, so the first step, finding that unit rate. Okay, so I look over here and I notice, oh, I've got Francesca. I'm going to call her Fran right here, just a shortcut. She does $25.50 for every 1/2 hour. Okay, and I have Elizabeth, good old Liz. She does $14.50 for every 1/4 hour or quarter hour. Okay. So with that in mind, I first, and one of the most important skills, we talked about it, it was in that video, is finding what?
Unit rate. Yeah.
And how do you find unit rate?
Using division.
Using division. You're absolutely right. So I need to turn this into a unit rate. Rate has what?
1, because the power of 1.
The power of 1, right? We talked about how it's a lot easier to find things using 1, correct?
Yeah.
Okay, so I'm going to slide down Fran's work right here. I'm going to say 2550 is equal to half an hour. I want to turn my denominator, my hour, into 1. Now, this is important, right? I want to turn it into 1 for this reason, right? Because this is looking for what the girls walk in 3 hours, okay? Remember I talked about you can turn either 1 into 1.
Yeah, okay.
So, how do I turn a 1/2 into 1?
You divide by itself.
Divide it by itself. So, divide by 1/2. Divide by 1/2. Now, keep in mind, one of the most important skills you might need to learn is what is half as a decimal.
And it's just 0.5.
It is 0.5, you're right. So I'm actually going to change this. I'm going to divide by 0.5, okay? So that's going to tell me what goes here. So I'm going to do 0.5 into 2550, right? I did make a video on dividing decimals, so I'm just going to skip the tutorial for that, and we're going to look to see how many 5 goes into 255.0, or 255, which in this case it goes 51 times. So she makes $51 in 1 hour. Fran does. Keep that in mind. $51 per hour. You with me?
Yeah, $51 per hour.
Yep. And then we're going to look at 1450, this lady here. And I'll tell you just a quick shortcut since it's a quarter of an hour. Really what I'm doing is I'm doing 1450 times 4. So I'm going to do that right now. So 1450, I'm just telling you 2 different ways to do it. Normally you would do division, but I just know that dividing by 1/4 is the same as multiplying by 4. Technically, dividing by half is the same thing as multiplying by 2.
Oh, crazy. So dividing by 1/3 is the same as multiplying by 3?
It is. You're absolutely right. But still doing division, it's just this is eventually you're going to have to do multiplication when you divide by a fraction.
Oh, yeah, okay, get it.
All right. So I'm going to do 0, 0, 2, 8, 1, 5. Move the decimal 2 times. I do have a video on multiplying decimals if you guys want to watch it. This person, good old Liz, makes $50 per hour. Okay, you with me?
Yeah.
Okay, so this is the important part. Okay, I'm going to erase this word because we know their unit rates now, right? We know that good old Fran makes $51 in 1 hour, and Elizabeth makes $50 in 1 hour. So, with that in mind, the variable here, or the thing that we may not know, we know it because of the problem. We know how much money they make, but we may not know how much they run, right? They'll go to that jogathon and they run 2 hours, 6 hours, 9 hours. Because that's the thing we don't know, we call that our variable. Are you with me?
Yeah, because it can change.
It can change. You're right. The amount of money they make per hour is not going to change. They're always going to make $51 per hour. But what they're not going to do the same of always is run the same amount of time. Does that make sense?
Yeah, I think so.
Okay. So with that in mind, we always have this number we want to know. First off, we want to know how much money they're going to raise. So I'm going to call that M. We're trying to figure out M. You with me?
Yeah.
Because that's their total. So that's the first step, right? You're looking for the total, and that's going to be your variable. In this case, the total is their money raised, right? So we're calling that M. Are you with me?
Yeah, gotcha.
Okay. So their total money raised. All right? You with me?
Yes, I said a yes. Okay.
Okay, all right. So I'm going to start with Fran. Fran, I know how much money she's going to make is going to be equal to 51H.
Wait, where'd you get each?
Ah, great question. Remember how we talked about H is the thing that's changing in this problem, right? And this is where writing equations are super useful because H is my total unknown. I don't know how many hours she's going to run. She could run 4, she could run 8, she could run 6, she could run 900. We don't know.
Yeah, we don't know.
But we do know, based on the problem, that she ran 3 hours because each girl ran 3 hours, right? So now, because I know what H is, it just told me, the problem told me it could have been 6, it could have been 5, it could have been 1900, but it said 3. So what I'm going to do is I'm going to, instead of putting H, because this is an equation, I'm going to put 3. And now when you see a variable and a number next to each other like this, it doesn't mean, oh, look, it's 513. That's bad. It's not. When they're next to each other like that, it means multiplication.
Multiplication. Okay, got it.
Because this is called the coefficient. The coefficient, the number next to the variable, means that's what you multiply by. Okay?
Multiply next to it. Got it. Got it. You guys got it? Multiply.
All right, multiply. Good. So I'm going to do 51 times 3, which is 153. Okay? So she raised $153. Now I'm going to do the same thing. I'm going to write another equation, right? How much Elizabeth makes. I just want your help. The key to this, guys, is use that unit rate, right? So basically, you know you're going to have a variable, so you take that number, make it the coefficient, and then a variable. So Our variable we used last time was what?
H for hours.
H for hours. So I'm going to still use H for hours. But what number would go in front of it this time?
50.
50, because that's my
Unit rate, or constant.
Exactly, that's my unit rate or constant proportionality. So with that in mind, I would then do the same thing. I'm just going to plug in 3 here. Does that mean it's 503?
No, it's multiplied. 50 times 3.
50 times 3, you're totally right, which is 150. So she gained $150 and she gained 153. So then I have my total over here. What do I need to do for their total?
Add together.
Good, so they would end up making $303 together. Okay, that's how you use equations in order to solve things. Now, this is a basic equation. I'm starting basic on purpose. But the reason you do this is now I could find any amount of hours they run. I could find how much money they make. If you're a business, they use this for how many hours somebody works. They need to pay an employee. They do all that stuff. They use equations that are built into the computer in order to solve it.
That's interesting.
Yeah. So this is what it might see like for a business. They see a graph, right? I talk about in my previous video on how to find the unit rate for this, or the slope. So I won't go into that. But the slope right here is 0.5 over 1, or it's basically, it costs 50 cents per 1 pound of banana. Okay, 50 cents. All right, and if I wanted to write that as an equation, here's what I would do. And what I love about this is you can use the variables here. Costs and b. Okay, so usually you're always going to be in the form of something like y equals mx or y equals kx. Okay, now keep in mind these actually represent the same thing, m and k. Okay,
Oh, I get it. Okay.
they're the same thing. Okay, oh, okay, you got it.
You're silly.
I know. So they're basically the same thing. It's going to be the constant proportionality, the unit rate, the slope, whatever is going to be those numbers that go in front of that x. The y is always going to be represented by this vertical, right? This vertical thing. So that's constant, or sorry, excuse me, that's the cost. So we're going to call it c, okay? Because we don't know what the cost is going to be. It could be anything depending on how many bananas we sell. But we do know one thing. What do we know?
The unit rate?
The unit rate or the slope is 0.5 or 50 cents. So I can put 0.5, right? And then what's the other variable? That's the x I want to look at.
B?
It is b, you're right. For bananas. You just wrote your first equation using slope and unit rate using a graph. C is equal to 0.5b. And here's where this is important, Tommy, because if I know that I have 2 pounds of bananas, look, here's 2, it should cost me $1 based on the graph, right? All I'm going to do is, instead of a b, I'm going to put a 2, right? Remember, this is not 0.52, it means multiply. And a half times 2, or 0.5 times 2, is 1. So my cost is going to be equal to $1. It basically told me my cost.
Oh, I think I get it.
Yeah, and slope is the same thing, right? Later, just as something you guys are going to see that we will eventually do a video on, is you'll also see y equals mx plus b. And this is one of the most popular things when it comes to high school equations, okay? B, which I'll tell you right now, but explain later, is where the graph crosses the y-axis. But all of these graphs we're using, they're all proportional relationships. They're all constant. They cross at 0. So really, this would be plus 0, but that doesn't affect the problem. That's why it's not there. Later, you might see a graph that might do this, and it crosses at 1. So the difference would be, that might be the same slope. The difference is it would be something like, it crosses at 1, would be that. That's really going to be the difference that we'll head to, but don't worry about that right now. Okay?
Okay, so wait. So what you're saying is I just need to divide, like in the last video, and then whatever my unit rate or my constant proportionality is, that's the number that goes in front of the variable?
That's the number that goes in front of the variable. You're totally right.
Oh, that's kind of easy.
It's kind of easy. Well, I'm glad it's kind of easy. That's kind of the point, isn't it? You make a video that ends up being easy.
Yeah, solving that problem was kind of tough, but I think I get it. If I watch it again, I might help.
If you watch it again, it might help. That's for sure. So just as a reminder, whatever your constant proportionality is, whatever your unit rate, you're always going to have your y is this, c. And this might have been something different. It might have been toasters, clocks, and whatever. You still make it c. I just used that first variable letter here. And this one I just used b. Right? C is equal to whatever my constant is, whatever my unit rate is, whatever my slope is. I put that number, and then my other missing variable, my x. Bam. So basically you end up getting something like y equals kx, where k is your slope, your unit rate, your constant proportionality. You with me?
Yeah. Can I use any letter?
You could really use any letter. That's a great point. A lot of mathematicians will use letters that go along with things, but you could use any letter because it doesn't matter. It's just an unknown, right? Like you could do this. I could do triangle is equal to zero point 0.5 circle. I probably shouldn't use circle. Let's use pokeball. Is that how you draw a pokeball?
Not really.
So triangle is equal to zero point 0.5 pokeball. The reason I say that is because really it doesn't matter. Whatever that pokeball is, I could put anything inside that pokeball, right?
Oh yeah, you could.
Is going to equal to a triangle. Right? It's just random, I understand, but it's just meant to represent an unknown, right? But based on the graph, based on information, that's where you find it.
Oh, okay. Thanks. I think that helped.
Hopefully, you guys can practice this, watch this. Really, the key is this is the simple start to writing equations. This is going to lead to more difficult equations, and then it's going to lead to solving them. All right, I hope you guys like this video. If you need some help in any other math, let me know.
Yeah, and don't forget to subscribe. Okay? Thanks, guys.